Hello, everyone. Today we are joining the course Security Basics for Non-Technical People. This is a two-part course. The first part covers the technical concepts, and the second part covers more of a project management, program management, risk side of things in the form of SDLC and others. But we will touch upon that in the second part. So, the first part today that we are going to cover is talking about the technical concepts that are relevant for non technical people, such as project managers, program managers, lawyers, legal team, sales, and marketing team, because security is everyone's responsibility in an organization. So, it is important for everyone to understand some of the technical aspects of how internet functions or what are your responsibilities in order to support information security, cybersecurity, data protection requirements within your organization. The topics we will cover today are shared responsibility model from the cloud services providers that you procure and use. This also will include the responsibilities like when you're procuring SaaS services or other services, cloud-based services that you may be using within your organization in addition to the major providers. Then we will go into a little bit of how the internet is designed and functions because that will give you a perspective of where things lies and what are the relevant areas when it comes to the questions you should be asking with your teams, with your IT or vendors as well. Then we will go into a little bit of the network concepts, and then we will touch into the APIs or application programming interfaces. So that will be the overview of the first course, quite a little bit technical, but bear with me, I will try to simplify as much as possible for you. So the first topic is shared responsibility model. So shared responsibility model from the cloud services providers are help us understand that what are the security obligations and responsibilities are of the provider as well as what are your responsibilities. So it is very important to know where that boundary is and how much you are allowed to do and what you can do and what you should do versus what the provider will do for you. This is important because a lot of the questions or a lot of the times companies and customers do not understand uh, the, the boundary when they are procuring a service or a product, and then the issue comes in when there are incidents or events that the vendor we can't do something, and in order to understand that we need to understand what that responsibility model looks like. So the major providers we are going to touch today is Microsoft, Azure, Google, AWS, and such. They all have very similar responsibility models. It's just you have to know what the verbiage that they use. So going into Microsoft responsibility model. So first of all, before we even go into the responsibility models of each provider, please understand that there are different kinds of services that these providers provide. So one is SaaS service, which is the most common. Then you have the PaaS, and then you have the IaaS, and then you have on-prem. So SaaS is a software as a service, which means previously a software that you would install on your computer is now available in the cloud, and all you have to do is procure it, log in, and it's there for you to use in a very similar way as you were using on the desktop. So that's one. Then PaaS. PaaS is a little more detailed in a sense that you're procuring a platform where you will develop your own application on top of that platform and then use it. So that's another aspect of it. Then the third aspect of it is infrastructure as a service. So what you're doing is you're procuring a bare bones structure and you will set up everything from scratch. So, and then you have on-prem, and which means that you're looking into your own setup altogether, and you will not be using the cloud, or there are some exceptions there, but we'll touch upon that briefly. To help you understand more simplistically, think of on-prem as buying a house, which means everything is your responsibility. And whether it's construction, whether it's renovation, whether it's maintenance, whether it's setup, payments, mortgage, everything is your responsibility. When it comes to infrastructure as a service, think of it as renting a house. And I'm clearly using the word house because there is a difference there, where you are procured the house, but then you have to do procuring an unfurnished house, and you have to set up everything. Platform as a service is, think of it as renting an apartment, where it can be furnished, it can be unfurnished, doesn't matter. But a lot of the aspects of utilities are covered in your rent, and the lighting is there and all that. You don't have to worry about. Uh, you can just go in and start setting up your own infrastructure to use it, to start setting up your own application to use it. Whereas in infrastructure as a service, when you're renting a house, there's a lot more details that you have to take care of in terms of, the security system that you would implement, keys, locks, and some more infrastructure related stuff that you have to do, which you don't have to do in a platform as a service. Think of SaaS as booking a hotel room. So even the responsibility for booking a hotel room is even less, meaning you don't have to cook. You can just go down in the bar or the restaurant to have food, and so forth. So the responsibility drops as you go through different types of services that you procure versus SaaS versus PaaS versus IS. On-prem is an interesting one. This is a traditional way of setting up services where you will take a room in your office building or somewhere else, or a hosting service provider where it's a physical place where you put your own servers and machines and configure everything through the system, so that you have to do all the work, and then it's connected to your network, and you're maintaining everything for that matter. Today in the cloud environment, as I said, hold on the on-prem side. So today in the cloud environment, on-prem can be treated as a private cloud network. So what you will do is you will procure the network space, and it can be a combination of all three, SaaS, PaaS, IaaS, and you will connect your network to that cloud, which means it's dedicated to you only, but it's more expensive. So SaaS, PaaS, IaaS are usually shared services, which means you're in the public cloud, versus on-prem is more of the private cloud distinction. So you can equate private cloud to on-prem in a way. So coming back to Microsoft's shared responsibility models here is, when you're looking at SaaS, the only responsibility you have is about the data, about the devices that you would connect, what identities and accounts that you would have, like single sign-on and such, and where that identity is coming from, and so forth and so forth. Versus when it comes to the actual application, the development of the application, updates on the application, what is the network connection looks like, what operating system that application is based on, or what are the physical devices behind the scenes that are actually that application is running on, you don't have to worry about. That's the responsibility of the provider of Microsoft. When it comes to PaaS, the middle tier responsibility varies by type versus application, network, and operating system. There is more flexibility to that, which means, and by flexibility, I mean that you have more responsibility and obligations that you will have to address. So the first part is consistent across board in all types of applications. And then you look into the responsibilities by type that you would uh, have to address. And those are also partial responsibilities in terms of it's shared between you and Microsoft versus infrastructure as a service, which means you have you have procured a bare bones house uh, that you've rented, which means the basic infrastructure is available, but it doesn't have any operating system, it doesn't have any network connections, it doesn't have any applications. So you have to procure the other aspects, like what operating system you want on the server, what network configurations you would want, how the network would be connected, how the systems and physical devices would be connected. That's your responsibility. You would not be procuring still the physical actual devices where the applications would be stored. It's more of the software responsibility that you will have. When it comes to infrastructure as a service, it's no longer partial. Everything is your responsibility. Still, physical devices are not your responsibility. That's still provided by Microsoft. However, when it comes to the software side of things, everything becomes your responsibility. And in on-prem, it's a physical empty space that you've procured. You will be buying the hardware, you will be buying the software, you will be doing everything. So in private cloud, the physical device aspect also becomes shared in a way instead of fully on your own. So there's a slight distinction on an on-prem, but you can, when I said equate private cloud to on-prem, that's what it is there are still on a physical device or physical layer side, you still own, you have the obligations and there are responsibilities aligned to it. So when you're procuring any service, your contract will uh, align to the service you're procuring or should align to service you're procuring. So that's where your legal team, or if you are a lawyer, commercial lawyer, then you should look into what type of service you're procuring. And if it is PaaS, SaaS, IS, then IS, then you're looking at your contract should reflect the right level of obligations that you would have or what providers would have. So please be mindful and considerate of what, or consider the responsibilities there. Similarly, Google has the same thing, just shown in a different order versus of the responsibility. So as I said, SaaS means content, access, that and usage, a bit of usage aspect. But when it comes to PaaS, you have how your application would be secured, if you want firewall and such. Some of the identity operations are not available in SaaS, but and PaaS, but there are some obligations because you still have to give access to the users. So or internally within your company, so those things would be available there. And similarly, you go into on-prem, which is equating to the private cloud in a way. AWS SRM is also similar. It clearly distinguishes what responsibilities the customer has and what responsibility AWS would have. And in that sense, it doesn't show SaaS PaaS IS because the approach for AWS is a little different. However, when it comes to actual software and hardware and different environments and firewalls that they have, is defined by AWS. You cannot define that. You can pick that you would want to use this firewall, but the options of what firewalls are available, for example, would be uh, available through what AWS has decided to provide. So just consider, depending on the providers that you're selecting or provider you're selecting, that it meets your environments, your company's requirements, and does not impact the risk adversely. Okay, at what time it is relevant to understand the model of and where does how does it impact the data is stored? So this is a question very important again from a vendor management standpoint, is where my data is stored, and do I have to comply with GDPR or CCPA or other data protection regulations that are that become relevant when the data goes outside certain regions. And in that sense, if you go back and take a look at the AWS, it tells you which regions it has the data in. And so when you're talking to the provider, what you do is not only you look into the functionality, but you also look to see what regions you can store the data in, or AWS can store the data in, or Microsoft or Google. So the regions are defined by the provider, that these are the regions available, and then you can choose from which regions that are available, which region you want to store the data in. So if I say I want to use AWS, I have option to store the data in US, in Canada, in EU, in UK, uh, Eastern Europe, non-EU countries, or Switzerland, Africa, South America, Japan, Australia, like all over the world. And so if I am an EU-based country, I would prefer to store my data in EU. Also, within EU, there are several regions or several countries you can store the data in. By default, usually it goes into Ireland, but you can also pick and choose, no, I want to store my data in Germany or in Netherlands or in France, depending on which region you are in. So if you're a French country, you would prefer to store your data in France. But if France was not an option for you, then you can pick another country which meets or which your company is okay to store your data in within EU. So that is important. Like in Germany, a lot of the companies prefer their data to be stored in Germany. They have a higher risk profile if it goes outside of Germany. So if you're procuring a provider, then you would want to see whether the data can be stored in EU, and within EU itself, can it be stored in Germany as well? So that is what you would want to address. Okay, next topic we are going to go into is OSI and TCP/IP models. This is the network model of how internet works today and how it was designed 30, 40, 50 years ago in 70s and 80s with OSI model. And that has modified slightly into TCP/IP model, but not much has changed after that. So the internet still functions on the same structure in a way, or same foundation as it was 30, 40 years ago. So we will not touch TCP/IP model in a lot of detail, but we will focus more on the OSI model because it gives you a little more distinction or clarity into the details of each layer. However, over the period of time, as we discuss things and details in this there, you will see why OSI was modified and why the layers were combined together. So OSI has 7 layers and TCP/IP has 4 or 5. In some places it says 5 layers, but 4 or 5 layers. And you will notice that the first 3 layers, application, presentation, session layer, are combined into application layer in TCP/IP, and the physical layer components, data link and physical layer, are combined into physical layer components. And that's because of the how it's structured, how those layers are used, or what are the devices and what is the functionality of those layers. So based on that, the TCP/IP model decided that let's simplify things a little bit for us, and this is where we combine the few layers in one. So now going into the OSI model, we go from top to bottom. So OSI layer says application layer is the top layer in the sense layer 7. And then you have the presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So physical layer is layer 1. So you go from layer 1 to layer 7, bottom to top, or top to bottom, however you are saying things. However, the reason I'm starting from the top is application layer is closest to the user. It's closest to you and me today. And so for us, it is better to understand what is closest to us, or it is easier to understand what's closest to us before we go into the technical details. So when it comes to communication, we are communicating at an application layer because that's the closest to us, that is what is accessible to us. And then the communication goes down across to somebody else. So if you and I are on a Teams call or a Zoom call, like in the session here, what's going to happen is Zoom is an application. So we are on the application layer. We connect to the application, we join the meeting, and that is all sitting in the application layer side of things. And then we move into and then this data, our video and the data, is going through the presentation layer, through the session layer, through the transport layer, into the physical layer, which is your actual physical router and switches and the wire, that the wire you have in your house that connects to the outside gateway of your provider, internet provider, and into the internet. And then it comes to me on my gateway and goes through the physical layer and goes on the top. So let's see what we have. So we communicate, each user, the sender, communicates from the application layer, and it goes down. And on the receiver side, when the data is received, it is received on a physical layer and then it goes up. So it is like, let's say you're going out for to a hotel or for a restaurant for having a dinner, and it's winter time. So what you do is you get ready, you wear a jacket, you wear scarves, clothes, take your keys, purse, everything, close the door, go out, go down the elevator, get into your car, drive to the restaurant, get out of the car, get through the gate, take off your jackets, scarves, put your purse down, go to the table, have food. So very similar to that perspective is like sender is sending stuff, so it is getting packed and getting ready and sent and is driven through the car on the physical layer over the internet. You go reach the restaurant, it reaches the receiver, and then it gets unpacked. And think of taking off the jackets and everything as unpacking. So that's how it works. Sorry about that. And when the receiver sends things back to the sender, it goes through the same process. So it will, the restaurant, you wear the jackets again, scarves, take your purse, uh, get out of the restaurant, get into your car, drive back to your home, and unpack yourself or take out the scarves and jackets, put your purse away, and so forth. So it's a same process that happens from sender to receiver, and when the message is sent back from receiver to sender. Okay, this is a very busy slide that we are looking at here. So again, taking the OSI model that we just touched upon, we will go break it down a little bit more to understand a little more technical aspect here, because that's where the meat starts to come in on the bones, and that is where we will see why it is relevant, because that's where the data breaches happen, or that's where you have to know what things are being run on. So when it comes to application layer, as I said, any application that you're running on is like Zoom, Teams, Outlook, Google, web browser, all of those are applications. So that's an application layer. Uh, for example, mail server, and then it has protocols that it uses and devices and applications. So just an example. So it's more related to content. Is more related to the data and structure and the format. So if I am in Zoom, I have video call, there's a structure to it. This is how it's going to be presented. You have options for checking who are the people available, who are what is in the chat, how it is going to show it to you, what are the functionalities available to you. So that's all application layer. When it comes to presentation layer, we go down, we are looking at encryption, we are looking at compression, and we are looking at transfer of the data. So here, what we are going to do is the data that we have started to, let's say I'm sending you a message in the chat in Zoom, then that content that you're putting in needs to be encrypted because it needs to be secure. So think of it as from a perspective of, let's say you're sending a postcard or sending a letter in an envelope to a person, or further securing it can be that you send that envelope that you are sending the letter in is even more secure, like the bank sent you the secure letters which are has additional security to it, like inside of the envelope um, is covered so that the content cannot be read. So those are additional security features that are there. So think of encryption security is like that. Compression is important because when you have large amounts of data, especially when it comes to photographs or videos or audio files, it is useful to compress them so that the size reduces. Uh, but there's also an issue with quality. So you would say, okay, I want a high quality, so I would not want to compress. So those all things are handled at a compression layer. And then you will decide how you would want to transfer. So there will be some transport protocols aligned attached to it as well. Session layer is important in a sense that this is where you are setting up a session. So I said this is a meeting at 1 p.m. on Thursday, May 10th, and ignore May 10th was not a Thursday, or was it? So what that looks like, and you connect to that session, or if you have a doctor's appointment, it has a time and date attached to it. So that is, and when you go to the doctor, you're creating a session and in a physical sense. So if you are in a virtual sense, you connect to the meeting, your computer will, or your application will sort of do a handshake with that meeting on us that's on the server, and that creates a session so that you can communicate it securely and nobody can jump into that session. So it's for you. Transport layer is where it's a heart of the network, because this is where you're starting to see how things will get transferred. So the first three layers are more on the user side of what is the closest to the user and relates to the user connection and the data, versus transport layer is where your transmission aspect, the physical transmission aspect, starts to show, and where your software starts to communicate with the physical device. So in this case, when the data is being transmitted, it will not be transmitted as a whole. It will break it down into chunks. So think of it as as a pie. Your data, your photograph that you're sending is a pie. But I can't eat the whole pie in one go. So I have to break it down. So I break it down into slice. And that's what transport layer does. So it will be responsible for breaking it down. And if when you receive data, it is responsible for doing the final uh, assembly of the different slices that you have. When it comes to network layer, it will further break down the slice. So think of that slice is too big for me, so I need to break it down further into packets or further bytes in order to eat that pie. I can't eat the whole slice in one go. So that's what it does. So it breaks it down into packets, and it's also responsible for assembly of the packets when it receives the data. Data link layer attaches further information and further labels in a sense that think of it as an address that you put on the letters that you're sending or postcard. And so should I send this to Australia? Should I send this to US? What that would look like. So it will create an actual right size bite that you can actually eat from the slice, and how long you have to chew and so forth. So if you're drinking water, you still take a sip, you know what size that sip you can take. And if it's a sip, then I have to swallow it. But if I'm eating something, then I have to chew it. So what that uh, address looks like, you have to understand that. And then the physical layer is responsible for actual transmission of the information to the sender or to the receiver. So, how does data protection team address cybersecurity issues when selecting a vendor? How the information is relevant when signing contracts, especially data breaches. So, let's go back to the previous slide and think of different things. So, first of all, you're looking at what application, what type of application you're using. Then you would want to know how secure it is. What are the security protocols that are being used? How the session is managed and such. And that's usually in the cloud services provider in the SaaS applications. That's where things stop. However, there are further things that you can take a look into is um, in terms of depending on which industry you're in, is the sectoral legislations that do you have to actually audit the data center, and can you audit the data center to see the physical layer side of things. And those are also the questions that become relevant here in this case when it comes to the cybersecurity issues. So, what type of encryption it is, what data is being transmitted by that application, who has access to that data, um, can I audit the applications? What are the disaster recovery or data breach procedures look like when the incident happens? What does the notification rules look like? Those all come into play. Also, if you go, you're doing logging and monitoring of the systems, so there may be other aspects that you would want to capture in the contracts. Okay, next topic is common protocols. And this is a mix of internet protocols that are used on the physical layer and the other application layers. But it is good to understand different things because sometimes it becomes relevant to see what those protocols are and what is the use and what is the purpose versus uh, sometimes it may not be relevant. It's just good to know. However, these are more common things that we would look into when incidents happen. So TCP/IP protocol is a combination of two protocols. One is TCP and one is IP, and they are responsible for the transport layer and the data link layer and the physical layer. So it moves from transport, works between transport layer and below uh, to transmit your data on over the internet reliably, and what are the routing and addressing mechanisms that need to be used. So if you know, on your every machine that is connected to the internet or network has an IP address. So it's more like literally like I can with my IP address of my computer, you can identify where that machine is, what network it is connected to, which country, which region that machine is connected to. You can almost pinpoint my physical location with my IP address. So that becomes personal information. And in a lot of regulations, IP address is considered as a personal information because of that reason. So IP protocol is responsible for addressing and routing. So since you know my IP address and what region it is in, now if I'm transmitting data, if I'm sending a postcard or to from my location to you, should I send this east or west or north or south? And what would be the path that network would take? That's covered in the IP protocol. Also, in the TCP protocol, it's more about reliability. So, if my slice of a pie is 5 slices, or my pie is broken into 5 slices, then all 5 slices should reach to the sender, right? And if each slice is broken down into 3 bytes, then all 3 bytes of that slice should reach to the sender, and then all 5 slices should reach to the receiver so that my data is combined correctly and the right message is delivered. Otherwise, either it can be corrupted, considered corrupted, or could not send, or only partial data is delivered. So that becomes an issue. And so it is important that the data is delivered in a reliable fashion. DHCP is a dynamic host configuration protocol, and it is responsible for assigning an IP address to a machine or a device. So as I said in the previous protocol, every machine has an IP address. And there are 2 ways to assign an IP address. One is that you physically assign a number to your machine, or it gets automatically assigned to you. So think of it as from a perspective that when a baby is born, you actually name them. So you are actually naming them yourself. It's not named by default or automatically. So that's why we all have different names. Otherwise, if it is an automatic name, you can be named as baby 1, baby 2, baby 3, baby 4, and so forth. So that is what the sort of a distinction between the dynamic protocol and the static IP assignment looks like. There are pros and cons to both. The reason, because there are so many devices in today's world and in the environment, that the dynamic host protocol is most commonly used, because then you just connect your device to the network, it has an IP address, and you can do what you need to do on the network. If it was a static IP address, then you would have to contact the IT or administrator of the network to assign an IP address to your machine before you can do things. So there is a distinction there. Plus, if it is a static IP address, there are security issues because your IP address would always remain the same. So you know where to connect or who to connect with, what number to connect to. So it becomes quite difficult. It's like in a company, if I use an employee ID, I don't know, I may not know which person that is. But if I know the name and the photograph, then I know, or the email address, then I can directly go to that person. That's why we always say assign a name or assign a person to something versus assign a team to something. So SNMP protocol is used for managing the network devices. So it's working on the physical device like 345, so routers, switches, and such. So it is used to monitor the health of those devices. So whether those devices are connected, are they performing at the right level, what is their capacity. So you would want to monitor the devices that are transmitting your data across. So if there is an issue, then the IT team or the data center team needs to address that network device so that uh, the data flows through correctly. And if there is an issue, if they are doing a maintenance, then the data needs to be rerouted to another device. All of that monitoring or all of that work needs to happen, and you can only identify uh, the issue if you're monitoring the device, and that's what this protocol allows you to do is the network. When it comes to domain name server, the next protocol is DNS, and this is responsible for assigning a domain to an IP address and back. Or, sorry, translates the name to IP. So if you look at your machine can be named as X PC or X Mac or something, whatever the configuration is. And however, that is for us users to identify the device. But when it comes to the devices that are interacting over the internet, they don't interact by name, they interact by IP address. So this is sort of like a mapping from a name to IP that it does. And it's like a directory in a way. So further example is, let's say my company's domain is guru.group. So there is, when it's hosted somewhere, it is given a certain IP address. And that's IP address is what is used to communicate. Let's say you're going on my website and your machine is going to communicate by the IP address of my website. Technically, behind the scenes, you will still see the name in the browser, but that's not how it works. The name is for us, the IP address is for the system behind the scenes. ARP is address resolution protocol. So this is uh, again, it addresses, so DNS and ARP works in a combination. So it maps the network address uh, to the IP address. And there's a slight distinction between the two. So domain name server is the name to an IP address. Give me a mapping of what is my name and the IP address. What is the employee name and what is the employee ID? Think of that. Versus ARP is where is that IP located? Like, is that employee ID in China or Australia or US or Germany or UK? So how should I route my traffic, or where should I direct my traffic if I'm communicating? That's what ARP does, is it kinds of the direction of what direction the data needs to be sent. So that's the mapping it has. And again, as I said, your IP address reflects which region it is. So ARP will say, okay, in this IP address, you need to send my data in this direction in order for it to reach the destination. ICMP protocol, this is a funny protocol. This is used to diagnose or get a feedback if there are errors. So think of it as a heartbeat or I'm alive protocol, and you're looking at you need to monitor the internet. So you may have already noticed that there may be outages sometimes, and what those outages look like, and where is that outage and that you need to address. And you can only know that if you're pinging, or if you're monitoring and you're getting the feedback from the device or the application or the system. So it's a kind of a heartbeat or a ping kind of a protocol. Okay, the next protocol is NTP. This protocol is used to synchronize the clock on your device or any device. In the networks, it is important that the clocks are synchronized to a central or a common clock so that the timing uh, is is aligned. And it is important to do that because there are applications that are time sensitive. And if your application has a delay or it's 2 minutes or 2 seconds or 2 milliseconds behind, they may not work or communicate. And that becomes an issue because it would fail or the packet would get dropped because it's not synchronized. And you will lose the communication or your data will get corrupted. So it is important that the clocks are synchronized to a central time. That is the reason why one of the things, like in your, we will always ask our IT team to say, get how often are you syncing the clocks of the laptops that we have uh, to a common time, because sometimes you'll see people are late in meetings because their laptop clock is behind. uh, I'm not saying that they are, but that is one of the reasons why, in addition to meeting overrunning and all the other stuff. But that is also one of the common reasons. Real-time protocol is used for delivering uh, audio and video. So previously, in other protocols, the transmission was happening more on the data side. So this is a different type of data where you can deliver audio and video. So in this meeting, or in this course, this course is being delivered based on the real-time protocol. The other protocols are related to more commonly used, and these are more important in a sense that these are application protocols, specific applications. On the left side, you're looking at mail protocols. So based on what mail you're using or what protocols are used when you're sending an email versus different protocols for file transfer and encryption on the right side. So SMTP is the main protocol to send an email, simple mail transfer protocol. So when you say you're sending an email from your machine to somebody else, they will receive it on their machine. However, when you send, it goes from your machine to your host provider server, and then from the host provider server to the receiver's host provider. And so SMTP is used between that server to server communication for mail. IMAP is used for downloading and retrieving the mails from the SMTP server. So on the receiver side, when the email is received by the server of the receiver, the person who you have sent to will open its mailbox and download the email, whether they see it on the browser or whether they have an application installed. So that communication is happening through IMAP. POP3 is a similar protocol. Uh, IMAP and POP3 are both downloading email protocols. POP3 is, the name is simply post office protocol, which is coming from the traditional mail post offices. So you drop a letter in a post box. The postman will collect the mail from the post box, send it to the post office, central post office, where it gets sent to the receiver's central post office in that city, and then it gets distributed and goes into the post box of the receiver. So post office to post office communication is SMTP. The post office to post box communication is can be IMAP or POP3. So today, like if you're using Microsoft or Gmail, either of the two uses IMAP as a default communication. However, back in the day, when I would say IMAP is a more newer protocol, so Gmail configuration is primarily IMAP versus Outlook was or Hotmail was POP3, and then they got both. But you can interchange, and they're still available. You can change them. SMIME is used to transmit non-ASCII characters, video, and audio data over an email. So if you recall previously or back in the day, 10, 15 years ago, when you were sending email, there, first of all, there was a size limit to how big your email can be. Secondly, when you would send a photograph, it would not allow you to send, or video or audio. And that is because it could not convert the character set into binary and to send it over SMTP. And so SMIME allows you to do that now. So if you're sending attachments with videos and audios in an email, then this is what's being used. Also, characters like Arabic, Urdu, the non ASCII characters, Chinese, Japanese, all of those are also were couldn't be sent. So that's additional. That's why your mail supports different languages other than English or Gregorian and other languages which have ASCII characters. So now the protocols relate to FTP, SFTP, which is think of it from a perspective of you want to share a file with somebody, and on your machine, you go on a folder, you create a folder, drop a file there, and you share it with that folder with somebody else. And so, what would you do is you'll send this is the location of the file, here's the username, password to log in and use an FTP protocol, file transfer protocol. And so the person would log in, use that location, log in into the user, and then access the file. It is a similar aspect like even our OneDrive or Google Drive or Box.com, Dropbox.com, but in a traditional sense, not from the cloud, but on a physical location standpoint. So you're opening a connection in your physical house to connect. So if you consider it from a house perspective and you store things in your garage, that means you have to give access to your garage for somebody to collect that information or that file or that data. Whereas if it was in the cloud, then all you have to do is give a physical location, the URL, and give access to it, and there's no connection that needs to be made. So it's a similar version as a cloud Dropbox. It's not a URL, but it's an FTP location. Secure SFTP is just one is clear text and another is encrypted. HTTP, HTTPS, this is the data that is transmitted over the web browser. So Dropbox and Box.com, Google Drive, now they have transferred from FTP, SFTP to HTTPS because they're sending it over the browser as opposed to a physical location from your garage. HTTP is plain text, so everything that you send on the browser, including your username, password, is in plain text, so anybody can see it. HTTPS is a secure, that means it's encrypted. And the encryption happens whether you're using TLS or SSH or SSL, which we'll touch now. So TLS is a transport layer protocol, transport layer security, and it's a protocol used for encrypting the data, which means it uses a combination of symmetric and asymmetric keys for encryption. SSH is a secure socket shell. That means it opens a secure environment for you to or access the data or write commands or things like that. Both of them would be encrypted. So like SSH, because it's a secure socket shell, it would be encrypted by the certificate and by SSL, secure socket layer certificate, and you can communicate. Similarly, TLS is the same thing. Which protocol is used to check the heartbeat of a service? You can take a look at the protocols and you can answer that question. Network concepts. This is an interesting approach. So traditionally, your network is being sent through the router that we saw in the OSI and TCP/IP models. This is more specific in a way that it works between layer 3 and 2. And what it does is when your packets are being formed, it will attach a label to it to say that only use this route over the network to send it to the receiver. So think of it as from a perspective that you're sending a postcard, but you're sending a postcard as a second class mail that has a delivery time of 5 days or something. So I'm okay to send it through train or ship or whatever that mechanism for that is. Versus if I have a priority delivery to be delivered by 9 a.m. tomorrow, then it needs to be delivered quicker. So the mail would go through a faster route or through airmail, and that's a similar mechanism that MPLS uses. So it's a multi-protocol label switching. So it attaches a label to the packet, and it can only go through the routers over the network where that label is present. It cannot go through any other routers. Let's The other example you can take is are going from destination A to B, and you have three routes that you can take. One is the shortest route, one is the scenic route, and one is through the city, like the normal route. But the label is attached to you because you're time pressed, so you're going to take the shortest route because you have a time constraint, that is the label that is attached to you. So you'll take the shortest route from A to B so that you reach fastest. Versus if there was no label attached, you can choose which of the three routes that you want to take. Whereas if there was another label attached, no, I should take a scenic route, then you can only go and take the scenic route. You cannot take the fastest route. You cannot take the other normal route. That's what the MPLS does. This is another network concept, SDN. So it's a software defined network. There are limitations to the use of SDN. It can be broadly used in a whole internet per se, but that is not where it is used because there are limits to the control and the network. So think from a perspective that you have a machine, you have your laptop, and you want to create three machines out of this laptop. So my physical layer, physical device and physical components are one, but you're using a software to break it down into three different components. So your physical devices or physical components are shared among the three logically separated systems. So that's what the software SDN is used primarily. So in the data environments on the servers where you have virtual machines, uh, or in the data centers where you have load balancers and you want to balance the load, you will use the software-defined network to allow for the traffic to go through in a certain way. And so in the SDN, you have a control plane, which is your software controller. And in the northbound interface is your applications and the softwares. And in the southbound is your devices, the network devices. So that's your physical component layer. So if I compare it to conventional, so you have physical devices that it gets transported through within the network. However, in the SDN, you have a controller that controls the applications to allow for physical devices access. So there is a separator in between. The next topic is APIs and types of APIs. So as a non-technical person, you don't necessarily need to know how the APIs are coded and such. What you need to know is the communication that the APIs are being used for. So for example, first of all, the definition of API. So API is a application programming interface. It's the communication between the two applications is based on a set of rules. So for example, here, if you've purchased something on the web, and if you've noticed, a lot of the times you will go on the website, you would purchase something, put it in the cart, and say click purchase or checkout. It will, and you'll fill all the information, billing and like mailing and all that information, and you and you click pay. It will go to a third location, go outside of that website you were procuring from, ask you to put the credit card information or the method of payment. Once the payment is successful, and it takes you back to the original application to say your payment was successful, your order is placed, this is your order ID number. That going out and coming back for the payment processing is the communication is based on API. So what you've done is, let's say you don't want to, and this is a risk-based communication and also based on the functionality as well. So you are procuring a service uh, for payment because you don't want to create your own application due to risk, due to compliance, due to regulations, whatnot. So you said, I will procure a service from a vendor who will handle all my payments and I will connect it to my application. So what you're sending the data from your cart information to that vendor through the API. So your application is communicating with another application through API, and it does something and it sends the message back to you that the order was successful or failed or whatever that may, and then you can do whatever you want with that. So that's essentially what the API is. Another example of API is when you're creating drop boxes. Let's say, for example, you have a contact us page and you have a list of countries and then the city state mapping. And because the countries sometimes add new cities and new states or zip codes, you create a mapping and you store the mapping by yourself. The other way to do it is use an API to say put the zip code in, and usually your country's uh, main company who is sending the mail will have that. So in US, USPS, in UK, Royal Mail, in Germany, Deutsche Post, they all have those systems that application APIs that you can connect to in your application to allow for the address information to be stored. So to be mapped to. So again, in the previous example with the payment processor, you were you have a two-way transaction. So there is a transaction for payment processing and the information coming back to you. In this case, in the address case, there is only a request for data check that is happening. So the user types the country, it pulls the information from the API of the mail service provider and drops it into your Dropbox. So that's the call. So there is a different transactions, different types. So you have a request and receive versus some actions that need to be taken on their side. So processing has to happen on their side. So there are different kinds of APIs that you use or purposes of APIs that you use. Sorry about that again. And in that, there are two different types of APIs. Ignore the XML and JSON, but SOAP and REST are two common APIs, types of APIs that are used for different purposes. However, today in common way, REST API is more commonly used. That is because REST works on small bite-sized chunks to communicate with, versus SOAP is looking at the whole object, send the whole object and collect the whole object, versus REST is like, okay, just send me this information and transfer the state in a very small bite-sized chunks. So that's what the APIs are about and have different purposes, and we use them all the time. As a non technical person, it is important when you're procuring a service and you're connecting it to your environment, you need to understand how it is connected, what is the encryption being used, what data will be transferred, what is the data that will be stored in the vendor environment. So like in the payment processing, the vendor will be storing the credit card of the user, the product procured, because you have to create a card in the catalog in the payment processing side of things. So there are different requirements that go there. So you have to understand what the use is of the API, how it is being used, and what data will be transferred in order to address the requirements from your end as a salesperson or a legal person. Even engineering needs to know that. So just to be clear. Okay. When is the label added to an MPLS network? So this is a question from the networking side of things. So I said the protocol works at layer 2.5 in between 3 and 4. So that's when the label would be added. Okay. In case of cloud service provider, can you make change to the use of MPLS network or vice versa? That is a no. If the cloud service provider is using an MPLS network, then you are limited to use the MPLS network versus uh, you cannot make a change. Note that MPLS layer is 2.5, which means you will not have access to physical environment. Okay, these are the useful links that you can use to review the different contents and different topics that we covered today. Thank you so much. We'll record the part 2 of the session as well and send it to you. Thank you.